There we go. Oh, man. I need Holly here to push the button. So anyway, we're here to episode 20. What was the number again? 204. Yes. 204. Man, it's 204 episodes. That's fun. So anyway, we're here for the episode of buildpacks. And before we go out, just we keep doing releases of Quarkus. And actually, there's a lot of stuff around AI. But if you go actually look into Quarkus, we keep having, there's a ton of stuff happening there. We actually should probably do an episode just of new stuff in Quarkus, because we have. I'm amazed at just the activity that's coming up right now. Like I think like a few months ago, I went through, hey, we should do an episode on Quarkus stuff, and I thought, oh, we got like 60, 80 repos, and I think we then had 110, and I think the number now is. I'm just gonna say, what do you think the number is today? I'm just actually gonna check.
148.
174. So there's a lot of stuff happening. So yeah, so anyway, go look at GitHub Quarkus for new stuff. We should we should do more blogs or something about the new stuff coming in. So anyway, and I'm actually surprised because there's. Anyway, we are here for you, and talk about build packs, and which is one of, I think, the well-known secrets that we actually have that in Quarkus. But I'll let you introduce yourself and explain what it's all about.
Yeah, indeed. Hi, so I'm Ozzy. I've been around in Quarkus for a bit, been around in Red Hat for a bit, and been around in IBM a lot longer, but it's all started for me quite a while back when IBM was doing this thing called Apsody, which was like a containerized build system. And
Absolutely.
Yeah, it didn't really catch on. It's archived. It's on GitHub now because everybody's ignored it and moved on to something else. But one of the things that we were looking at when we got there was, well, what else? What were other people doing in the way of containerized build? And buildpacks was on the horizon at the time. And if you've ever messed with things like Cloud Foundry and all that kind of stuff, then you've heard of Cloud Foundry build packs. But this is where we start to be different, which is why I made sure that title foil, unlike my title foil on my slides, said CNCF build packs, because there's a big difference between Cloud Foundry build packs and CNCF build packs, sort of.
Oh, we'll see. Okay, interesting.
Right. So let's pop up the first bit. So yes, CNCF build packs, we've got our own proper specification. It was all donated over to CNCF, and it's a way to basically create containers for your applications. You can run them via Docker or anything else, whereas Cloud Foundry build packs is just a way to run an application remotely in Cloud Foundry. So this is, CNCF build packs is generic stuff that if you want to build a container and run it in Kube, or if you want to run it just locally in Docker or whatever, then this works very well for you. So we're going to be talking about a few things today within this stuff. So obviously CNCF build packs, we've got to explain roughly what build packs are, what are the key things that are important when we're talking about that. And then we'll be talking a little bit about Paquito, which is an ecosystem that's built on top of the CNCF specification. And yeah, because it's one thing to have a specification, but you generally need something to use it. And it's not a reference implementation by any means, but it's, in my mind, it's one of the bigger build packs ecosystems that's out there, certainly one of the more popular ones. So we'll be talking about why that's important and what we've been doing from a Red Hat perspective with Paquito upstream. And then lastly, we'll be tying that together with Quarkus and saying, okay, so now you understand what build packs are and what they do, this is how you can use them from Quarkus, and what do they mean to you from that point of view. So
just remind me about history. Build packs came out of what's it called? It was like a cloud service, not Paquito, not CNCF, or not anything. It was a
originally build packs would have been Cloud Foundry build packs going right way back with CF and stuff. But that specification evolved, and with a bunch of people who are no longer involved in the CNCF project, kind of became, well, how can you take the concepts behind CNCF behind CF build packs and turn it into CNCF build packs. I'm not going to get into that journey because that's a very long-winded one. But enough said that we'll discuss here what's important for what makes a build pack. Everything we'll be talking about today will be CNCF build packs. We won't be talking about Foundry stuff.
Well, I was saying Heroku used build packs, right? Or that's what I remember it from, right?
Yes, and Heroku now also have an ecosystem of Cloud Foundry. I must get my brain in gear. Heroku also have an ecosystem of CNCF build packs, just like Paquito does. Google has one as well. There are a bunch of others out there, and there are a bunch of companies that are using build packs internally that have their own builders and stuff like that they're making. So they've got essentially their own internal ecosystems. Well, I mean, via Quarkus, we're plugging all of this stuff in via the container image extensions, which is the standard blob on the side of Quarkus. I mean, it feels like Quarkus's poor cousin sometimes when I'm trying to write code for it, but I'll get into why later. But it's the thing that lets Quarkus build an application into a container. And we support off the top of our head like Jib, Docker, Podman, OpenShift, and buildpacks, which is quite a set, of which S2I, Docker, and buildpacks probably the most well-known of those, I guess.
What I call it is you can of course take any Quarkus is just a Java app, so you can of course do anything you can do with Spring or Micronaut or Wildfly or whatever and deploy. But we have these specific, let's call them opinionated container images.
Yes.
That says, hey, and make use of our build time information to generate a better S2I, a better Docker, a better build pack, that kind of thing. So.
And that's the whole goal, isn't it? I mean, anybody could write a Docker file and then slap a Java app into there with a JVM and set it up so that runs as an application. But the whole point about using this is you let somebody else start making those decisions for you with the vague hope that somebody else knows more about this than you do and will build you an image that's smarter than the one that you would have built with your 2 minutes on Stack Overflow. Yeah. And generally, that's true. Of course, if you really know what you're doing, then you might bypass this anyway. But build packs is kind of interesting compared with all of those other ones in that it's actually modular, and the different parts that contribute to your final application are pluggable and replaceable, and that's what's given it a lot of momentum in the community because stuff like S2I and the rest of it, you can't really plug that stuff together that way. Okay, so. This was supposed to be an overview slide, so I shouldn't get into too much detail. It's always my problem. I have a list of stuff I shouldn't talk about, so I'll talk about them. So here we go with some fantastic images supplied by some AI generation toolkit that we won't talk about. But this is the highest level overview I could come up with build packs, where when you're going to use build packs to build an application, it's going to use this series of containers to build and package the application, right? Each container is like a phase, and each of the phases has a separate goals. The important phases that we care about are the ones detect, generate, and build, because the detect phase is basically a chance for all of the build packs that are within a builder image to choose if they wish to participate in the build or not. And that's really important because you can have a builder image that could build a Quarkus app, a Java app, a Node app, a Ruby app, a Python app. And so, if you're pointing that builder image at your Quarkus app, you probably don't want the Python build packs to be involved. So just like everything else, when the detect phase runs, each of the build packs and extensions in the image gets a chance to look at the application and go, yeah, I'm in or I'm not in, which is why those little androids have their hands up and some of them are sleeping and don't. The ones that say they do want to be involved in the build, that isn't a guarantee that they will be, because the build pack detect phase, when it runs, it then has to build a viable build plan from everybody who said they wanted to be involved. So it will then select the actual build packs that will be involved and will print out a little list saying these guys are going to be contributing. And then it starts to spin up the real build. And that's where the generate and build phase come in. These are analogs of each other. Generate is for extensions, build is for build packs, right? And for the things that have been chosen to participate within this build, the extensions or the build packs that have been chosen, they then get their build phase or their generate phase driven on them. And for extensions, the generate phase gets to output a bunch of Docker files that say, I need to extend the builder image, or I need to extend the run image, or I need to change the run image to something else. And for a build pack, that's something like, I want to install Maven, I want to install Java, I want to perform a build with a build tool, that kind of stuff. So that's kind of where we're headed to with the important bits along there. So builder image is the thing. Phases are important because they're the steps that are going to get run. Each phase is run as a separate container, which means we can isolate the information that's passed to each phase. So we don't have to pass credentials to phases that don't need to worry about it, that kind of stuff. Yeah, here we go. So we got generate step is able then to create Docker files. So why do we need these? Well, buildpacks has this very strict rule from day one that a build pack should not be able to modify a system image. And under that, guys, build packs do not run as root. They don't have root access, and they should not attempt to obtain root access through backdoor methods, which would be trivial, but slightly breaks the spirit, So we started working with the CNCF build pack specification back in late 2020, which seems an awful long time ago for me now. Basically to talk with them to say, well, we've got a problem, right? Because when you look at the way that Paquito installs Java, it's a build pack. They download a Java runtime as a tarball, and then they unpack that into the builder image, and then they use that unpacked JDK to do their work.
Yeah.
Well, within a UBI world, which is kind of where we're coming from a Red Hat perspective, we wanted to be able to do the equivalent of DNF install Java, because we don't distribute our runtimes.
Yeah, you want to. It's not even because I think when I explain it to people think it's a Red Hat thing. We want to trust the packaging system we are already running in. In this case, Red Hat Linux or Fedora or Ubuntu or
UBI base image,
right. And this is actually funny, like when you hear about build, because what you just said is what I think most people who know build package are like, oh yeah, it's a way to install and do things, and great. But then we realize they're basically downloading random stuff from the internet and no consistent verification.
No, that's not quite fair. I mean, at least within the Paquito ecosystem, the dependencies are very well managed. And when Paquito goes and downloads a version of Java, it guarantees it will get you the same one every time for the builder image that you were running. So if you're
you're trusting the Paquito system of images. There's no way for others to there were not a way to say, hey, I want to use Red Hat's way, or I want to get.
And this was our comment at the beginning when we started interacting with the buildpacks community. Was look, we've got an established way of distributing and installing runtimes, but it just doesn't work with you guys because it needs root access, because it's going to install the JDK to the system locations. It can't install it to a user directory just for a user like that. And I mean, there was some sort of discussion about whether it would be easier to change an entire specification to allow us to install things via Docker files, or whether it would be easier to change our packaging system to distribute our runtimes as tarballs. We went with changing a specification. I think that says lots. So the reason why we're doing all this is, of course, is when we're looking at our UBI image that we've been creating upstream in Paquito, we start out with UBI minimal, which has no runtimes in it at all. And we use an extension to basically generate a Docker file that will install Java for us, which gets us into the next part when, once we've finished running the generate phases for all of the extensions, we then start running the build phase for all of those build packs. And critically, that runs in the context of the extended builder image. So when the build packs start running, they find that they've now got access to all of those nice, tasty system packages that we just installed via our extension. So as far as we're concerned, we've now achieved the same goal as what Paquito was doing when it was installing a tarball for Java. We've simply had an extension install that via DNF, and then the rest of the build can proceed relatively normal. It's worth pointing out at this point that the whole, we're not trying to create things as root, whatever, is that the side effect of that is whilst the build is running, build doesn't just get to create stuff wherever it wants. It's creating directories in a folder called the layers directory. And each of those folders can end up becoming a layer in the run image, when the run image is the image that it will be produced for you to use in production with the application. So the builder image is just the context while we're doing the build, and it's creating all of these directories. And those directories can say that they want to be part of the run image. They want to be a cache, so that if you rebuild the image, the cache will be reinflated for you to use again. Or you can say this is strictly build time only, and I don't care about this ever again. And then once all of the build packs have finished their build phase, those layers are then taken and stacked on top of the designated run image, and then that produces your final application.
So just because maybe I missed here. So when for example, today there is and correct me if I'm wrong here, there is a Paquito Java build pack.
There are several.
Yeah. Are we creating copies of those, or are we saying, hey, Paquito, if you want to install Java, please call this thing to install it? Which approach are you taking here?
So you're going a little deeper than I go in this presentation, but essentially when build packs are saying that they're going to be part of a build, they can say that they require things, and they can say that they will provide things. And I use the term things deliberately vaguely because essentially it's just a string that ends up in a build plan. So for instance, the Maven build says that it requires there to be a JDK present, otherwise it can't run. And the build pack that used to provide Java would say that it provides JDK. And that's why back at the beginning when I was saying that when detect asks everybody, hey, who wants to be involved in this build? And half of them stick their hand up. It then goes through and says, okay, but you require something that nobody's going to provide. So you're not going to be part of the build. And the rest of you will get together and figure out how to do the build in a minute. And so that's how you end up with this today, where Maven says, I need a JDK, and Bellsoft Liberica, for instance, says, I provide a JDK, and so it all gets put together and it works. What we're doing with an extension is we've supplied an extension that also says, I provide a JDK. By nature of the fact that the spec will always run extensions first, because it has to, therefore we jump in before and we supply our JDK. And then Bellsoft goes to run about 3 minutes later and finds out, oh, well, I guess I'm not needed anymore. And it just quietly walks away. And then Maven goes to run and says, I need a JDK. And of course, there's the one that we provided for it. So as far as what we've done from a UBI perspective for Paquito, we're reusing easily 95% of the Paquito infrastructure and architecture is exactly as is. This is why we're contributing and working with them. The only parts we had to do was figure out how to get the runtimes to be installed via DNF at this stage.
Very cool.
So, I mean, this slide is talking a little bit about the builder images, because builder image is like the main distributable component of build pack builds, and it's critical to understand that there are many of these things out there, right? Because we've just been talking a lot now about the UBI Paquito image, but of course the rest of the Paquito images are all based around Ubuntu, and there's Ubuntu Jammy. I think they've just deprecated the Ubuntu Bionic ones that were out there for a while, but there's different versions of those as well, because if you think of a builder image like a minibus full of builders, thank you ChatGPT again, then which build packs are part of it depend an awful lot on what you're trying to do. So if you were building a builder image that was just for Java, then you would only have like a limited set of build packs inside it. But if you were building one that wanted to do Java and Node and whatever else, then the bus gets a bit bigger. The problem is that the larger the bus gets, eventually people start getting annoyed because there's no parking when they try to download the thing every time, because it's getting quite unwieldy. So we talk about the fact that a builder image contains build packs and extensions. Think of extensions in the same way as you think of build packs, except there's special cases. And it also contains this one special group of binaries called the lifecycle, because we were talking about running each of these containers as a phase. We're going to run a detect phase, we're going to run a generate phase, we're going to run a build phase. Well, each of those phases is actually a lifecycle binary that we're going to run, because that's the logic that's actually going to execute. Because we need to know from a perspective of when this phase runs, what does that mean? What does running a phase mean? Well, it means we run the corresponding lifecycle binary inside the context of the build container, passing it the arguments for everything we care about, and it will execute that phase for us. And the live
does this?
Yep, go ahead.
Go ahead. Just build packs is executing solely inside a container, or is there also stuff outside a container?
So yes, the build itself will usually happen inside containers. It would be possible to create something that didn't do that, but the vast majority of cases today do. I'm aware of a company that doesn't, but that's their internal implementation.
Yeah.
Okay.
Anyway, we'll see, because I'm now you're presenting this. I'm realizing this is because we have this thing in other similar for the Docker files. The way we generate Docker files in Quarkus, we want to get to a point where extensions can decorate them, like contribute. I'm not gonna say faces, but it's like very similar. Like, hey, the what's it called? Like, say for example, the I think Clement's gonna kill me, but let's say it's the Kafka. When you build native image, it has to have a certain native library on the installed. The extension knows that. Where we in Quarkus we would like to at least offer the option of the extension saying, hey, if everything is fine, please put this one. Whereas buildpack goes the other way of saying, you have to know to add the Kafka aware buildpack to it. So anyway, I'm just wondering if there is a phase where we could influence buildpack to add these native stuff.
You would create an extension, because I mean, if you want to do natives, it depends. If the native stuff has to be installed as a system library, like via DNF, you would use an extension. If it's just a library that needs to sit alongside the application in some manner, then you could get away with just doing it in a build pack, because it is possible. We don't support it with any image that's public today, but it is possible to do a native Quarkus build via build packs as well. But that depends upon having a custom builder image, which is something that we're talking about slightly here, which is that obviously once you start looking at the builder images and getting into edge case scenarios, you start realizing very quickly that although buildpacks tries very hard to be one size fits all, you will inevitably hit a situation where you want to do something that no existing builder image does. And the great thing is it's really trivial to take somebody else's builder image, just add a few more extensions and build packs to it, and then make that your builder image that you run for your builds from now on.
I think and again, correct me wrong, like we had there was a Java Paquito build pack, which added support for Spring and a few others. And then I think we had a Quarkus extension, some Quarkus standing in there. That's when you picked up and helped going in, and then we hit the issue about which JDK to use, and that I think the Spring one, together with the Java version of it, was assuming that it was always a fat Java or something.
Yes, I mean, this is part of this. There is a Quarkus build pack. We talk about that a bit later as well. The Quarkus build pack comes up. And its job is pretty much to provide configuration to Maven so that Maven does the right thing when it does the Quarkus build as well. So, I think that's about all we need to say for that lot. So many builder images. I was just saying that, when you start looking out there, you'll find that Paquito, Google, Heroku are all publishing builder images that you can use. Paquito's offering a selection, so you get some that have every single runtime they support. That one is truly massive, and they've hit things that are close to the layer limit for Docker images. And I've worked an awful lot with the Podman team over the last couple of years as I've been debugging and working this, and the sort of eyebrow raised comments that come back when I pass them some of my sample images are like, I'm not sure I've seen an image that had that many layers before. I'm like, yep.
Oh, the actual
layers within the image. They've got to the point with the large Paquito image where it was actually starting to hit the layer limit for a builder image, so you couldn't actually do much once you'd hit it. So to decide a little bit more. So now they're starting to look at how to flatten all of these layers together when they're producing them, which is great. So as well as having all of these selections of stuff, they also offer this UBI-based builder image, and that was entirely our fault. Now, that was us because after we'd got the spec change done up in CNCF build packs to say, hey, we can now have extensions that can install things, we then realized that we've now got a choice. Do we go off and create the Red Hat build pack ecosystem, or do we go and find an ecosystem that already does much of what we need and start working with them? And I think personally, the latter approach is a lot more in keeping with the open source approach of going out and finding new friends. So we went that way. And Paquito, thankfully, at that point had a big thing where they had their roadmap published. And on their roadmap was, we want to do UBI-based builder images. So we submitted the RFC that explained how we were going to do it. That got accepted, and we started working on that. And now we've got to the point where there is a published UBI Paquito builder image. It uses extensions. It will use the extension to install the Java level that's appropriate. So, if your application needs Java 21, then that is detected normally using the normal Paquito method. And then we will install the appropriate Java level via the extension. It's definitely worth pointing out that if you're using the UBI-based Paquito builder, your application will end up on a UBI container. And I know that's important to some people for support reasons and that kind of stuff. So, right. So then we start talking about how do we run all these builds, right? Because we've talked about what is a build pack build and the rest of it. But how do we actually end up executing these things? Because we say it's a sequence of containers. Well, that is a build pack platform. Anything that runs a build pack build is a build pack platform, and it's defined by the specification. The specification lays out, these are the phases that should be executed. These are the arguments you should pass to the lifecycle binaries. Things get rather confusing quite quickly when you look into this stuff, and I'm going to keep this light here. But the problem is that we release new versions of the specification regularly. Like we had to release a new version of the spec that introduced extensions. So what happens to all the build pack platforms that don't understand that? Well, they claim support for a limited range of versions of the spec. Extensions came out at 0.10, which was in 2021. So anything that does support 0.10 or above can't run with extensions. And we'll see examples of that in a minute. So you end up with a build pack platform having to implement multiple versions of the spec concurrently. And when you run a build pack build, it looks at the builder image, which says, hey, I need these versions of the spec. And then it looks at itself and says, well, I provide these versions of the spec. And it intersects the two and says, well, that's the version I'm going to pick for this build, which is, quite easy to do once you've figured it all out. So when you need to build your Quarkus app, you've got two easy ways to do this. We can use Pack. Pack is the reference platform implementation. I mean, it's way more than that, but it's also, it's written in Go. It's provided by the buildpacks team themselves. That's CNCF buildpacks, and it's the Swiss Army knife of everything to do with buildpacks. You can quite happily use that to build your Quarkus app by just doing pack build within the directory. Off it goes, and it'll produce you your app. Or we can use the container image extensions from Quarkus, either via Quarkus command line or directly via Maven Gradle. We've got a full Java implementation of a build pack platform implementation. It's, as far as I'm aware, it is the only complete Java implementation that's out there today that supports all the different versions of the spec. It's worth pointing out Spring Boot has one. Spring Boot's one does not support extensions and hasn't received significant spec upgrades in a while now.
Okay, so if you want to use, this, because what you're doing, the extension to you work with UBI images and other providers is not tied to Quarkus. That's just a build pack feature. But
correct.
Spring doesn't implement.
Yeah, so you cannot use our UBI builder image with Spring's boot plugin today, because it'll get to the point where it says, hey, but this image is using extensions. I don't understand what extensions are. In fact, what it'll actually say is this builder image requires spec revision. What it should say is this builder image requires spec revision 0.10 or above, and I only implement up to blah. But they didn't implement that in the boot plugin. It claims support for infinity versions going forward. So it just crashes miserably when it tries to run. There's a lot of work to go there. I've been trying to help the guys over there as well recently because they've been hitting trouble with Podman. I have learned more about volume ownership and mount points within container runtimes than I would ever care to need in 3 lifetimes whilst implementing this. The rules regarding who owns a volume when it is mounted to an existing or a non-existing mount point within a container depend not just on the runtime that you're using, if it's Podman or Docker, but also whether that volume has ever been mounted previously, to which ownership, and if it was root or root. Yeah, if it was owned by root. There's a lot of mess in there. We've sorted it all out in our implementation. Pack has it all sorted out as well. Spring's one is optimistic. It'll get there eventually, maybe. So that's the platform impulse that are out there. When we're talking about the Paquito UBI builder, which does work with the Quarkus thing, it can currently build, like we care about this from a Quarkus perspective, Node.js 16, 18, and 20. They're all included. And we will build for JDKs 8, 11, 17, and 21. Now, some of those are pretty old. And you might ask yourself, well, why do we care? Because obviously Quarkus is what it requires 17 minimum now, I think.
Yeah.
But of course, there will be older Quarkus apps out there. And there's no reason why you couldn't, with a bit of magic, end up wanting to build an older Quarkus app with the UBI builder. You won't be building it using the Quarkus container image extension because the older Quarkus won't have it. But you could build that older Quarkus app using Pack, using the UBI builder. This is where the whole mess of this thing starts to become fun, because you've got the UBI builder image that can be used from any platform implementation to build any type of app, which could include a Quarkus app. So somebody could be looking at a Quarkus 2 application and trying to build it with a UBI builder image, and we'll do the best we can. So the other thing that we include within the Paquito UBI builder is the Quarkus build pack, which is something that you've just alluded to a little bit earlier. And that one is important because it recognizes Quarkus projects when it's looking at it. Well, technically it recognizes Maven Quarkus projects, we should say. But when it looks at a project and says, hey, this is a Quarkus project, what it does is it outputs a whole bunch load of configuration into the build pack build while it's running, that says that when the Maven plugin goes to run later on, when the Maven build pack runs to perform the build, a whole load of extra arguments are added that force the packaging type of the application over to a particular type, that set a whole load of other flags that say where the binaries will be. And yes, originally it had to be set to build it as an Uber jar. No, that's not quite the same. Everything's done with proper layering and a few bits and pieces. So, but the whole point of this is we can update how the Quarkus build pack works, we can update how the Maven build pack works, and publish newer versions of the builders as we go, and the build will benefit from that as we move forwards. Where do we get to then? What can't it do? What can't the UBI builder do? Well, it's a funny thing to talk about, but we have to mention the stuff that doesn't work, and that would be native compilation. I did get close to that, but I ran out of time on it. So that's something I'd love to revisit one day. But as Max knows, there is priorities for time to work on these things. So that's something we'll look at. If somebody's really critically after it, we can solve it, but not just yet.
So it's what do you call it? Is the issue here just, hey, we want to be able to use Mandrel and not GraalVM, or is it more than just pick up the builder?
It came down to Mandrel and GraalVM knowing how to get that installed in a way that would work with the existing native build packs that exist within Paquito. There is a way to make it work. Yeah, okay. I came close to achieving that, but I didn't manage to pull it together in time before I gave up on that. UBI 9 is the next thing, because obviously we're based around UBI 8 at the moment, and that goes end of life in a while. So we'll need to move over to UBI 9 as soon as we can. Multi-arch is a very big thing in Paquito at the moment. It's being worked on, but it's also being worked on upstream in CNCF build packs. And until all of that resolves itself, once the rest of Paquito's done multi-arch, we'll roll it out to the UBI image. It's not a difficult thing. It's just...
So multi-arch is that one build can spit out multiple ones, or is it that you can build in one to produce the other? Or
a bit of both if it's done correctly. Certainly it will enable you to do things like build an x86 image from an M1 Mac, which will be quite handy for people who want to build production images. But also it should let you to be able to generate multiples just by passing a flag over to say, I need to generate these as well. Air gapping is something that was important that we didn't get to, but it should be doable, but it most likely it'll need a custom builder image today to achieve that. So that's one of those ones that I'm not saying that this stuff is impossible, but if you've got people who are interested in this sort of stuff, then it's a question of walking them through building a custom builder rather than walking through what arguments they're going to use. So we've covered some of this. Where can we use it today? We can use it via the container image extension, via pack. We use it via JBang directly, which, via, as I call it, a DIY CLI at that point, because you're writing all of the stuff that does the argument parsing, because I didn't. But yes, we use JBang extensively to test the Snowdrop build pack library. And I should say at this point, the Snowdrop build pack library is the Java platform implementation that Quarkus is resting upon. So that is, you could embed that in anything today, and it would let you then build build pack builds from a Java application. CI/CD pipelines, in theory, should be able to build this. I know we have a colleague who's very busily, actively working on trying to update it to support extensions. Most of them today out there do not support extensions because there's just not been the support. There's not been the interest in it that way.
In Tecton?
Yeah, exactly. So because the UBI builder image has only been out there for a while, and there are relatively few builders that rely upon extensions, the uptake of extensions in platform implementations is sluggish at the moment. As I say, Spring Boot hasn't done it. Pack has, obviously we have, and the Tecton example pipeline needs an update, but we're working on it. It's something that should be happening. So what can Quarkus do with build packs through this? This is to the last foil I've got. You'll be glad to hear. And we've got a full Java implementation. We implement versions 0.7 through to 0.12 of the spec. It's at 0.14, but the last two revisions haven't added anything significant that would affect what we're doing, so we haven't gone back to change that yet. We've got support for custom builder run images, so you can tell the container image support that you want to build with this builder or that builder or whatever else. By default, it's going to use the UBI builder from Paquito, but if you don't want that, you can easily override that. We support custom lifecycle images. When we were talking about the bus and the lifecycle driving it and the lifecycle providing all of those binaries, from a security aspect, some people like to make sure that the lifecycle that's used is one that they have sourced rather than one that's coming from the builder image that they've been given. It offers a minimal security bump, I guess. I mean, but if you're going to allow extensions to run, they could probably almost do anything that a custom lifecycle binary could anyway. Daemon and registry mode builds. By default, we're running in daemon mode. This is this thing where we will remount the Docker or Podman socket into the lifecycle container so that it can do its job directly. So when the lifecycle needs to pull something, it can talk directly to the daemon and do all of that. That's frowned upon in so many circles for security reasons that are very, very good and should never be used. So we also support registry mode, where we will build directly against the target registry. Registry mode, of course, then requires authentication, so we have to be able to do authenticated registry access. We've got Docker and Podman compatibility. We work absolutely flawlessly with Podman. I promise this. We'll see how we get it on with that. But yes, it's Podman. We assume that if you have Podman installed, that you want to use Podman. This can cause some interesting things because I believe the GitHub Ubuntu runners have, if you're into running actions from GitHub, they have both Podman and Docker installed, but Podman is a very, very old version. So your best bet if you're trying to make stuff run in an action is to either uninstall the Podman that was there and update it yourself, or uninstall it and use the Docker that was provided in it, because both will work quite well. If you are using Podman, you do need to start Podman socket, the system service, to make that run. It can be a user socket. We run with Podman rootless as well, no problems at all. And you probably need to reconfigure the timeouts. And if you have ever used test containers, you'll know what I mean from that there's basically a bit of a disagreement between the Java Docker library and the implementation of Podman as to exactly when a socket can be reused or when it should time out. So you have to customize that. We've got all that in the FAQ and stuff. So I think I was just going to show what it looks like to run one of these as well.
Yeah, let's do that.
So, hold on, let me sign back into this thing. Doink. So we have here a straight-looking little Quarkus app that I just created, and I added the Quarkus container image extension while I was doing all that lot. So if we have a look at the pom.xml, we'll see in here, where have we got it? Should have the container image extension floating around in there somewhere, or maybe not.
It's down.
Down.
You just scroll back.
Down.
There
we go.
Down. There's a.
Yeah.
Yes, this is a normal Quarkus Crate app. Then plus add the image build pack.
Yeah, exactly. So there's nothing else. So it's the stock app in every other way. And then let's just scroll back through a few of these so I don't have to type large amounts of stuff. There, I guess that's the shortest and simplest way to kick off a build, saying I want to do a container image build. It's going to default to build packs because that's the only container image extension that's installed. And it's worth pointing out while this thing is running, because this will take a few seconds to run, that this is actually going to recompile the whole application within the build pack as well. It's possible to actually just include the jar files that you want, and it will skip all the compilation phase. But yeah, that's you go. So you can see that whilst it's getting bits, this bit here is talking about the fact that it's recognized that we're going to use Podman, and it's telling me the Docker host and Docker socket is going to use, because that varies an awful lot. Because Podman on Linux, which this is running as a VM, is one trick. Podman on Mac or on Windows is using a VM to host the Podman engine, which means that I need to know the path for the Docker socket inside the Podman VM, not the path that it has on your host. So it gets, and that's why it's all got this logic in there that now asks Podman to see, hey, what path should I be using from you? It does all that. So now we're getting to the point where it's now installing the package. So you see that this is the extension that's running now. And we say we're enabling, we're going to install Java packages, runtime, whatever. We're also going to install Perl as well because it's a dependency. And this is now UBI.
What has a dependency?
Something does, yeah. The only thing that I tell it to install from the Java extension is just install like Java 17 runtime or something like that, or Java 17 JDK or whatever. There's a package, like a meta package for UBI that will install the Java JDK and stuff. Sure. And you can see it includes things like libx11 and all the rest of it that we're really not going to be using, but it doesn't matter too much. I mean, again, this is only downloading to install into the builder image. The run image, we're going to be using one of the published, well, it's derived from one of the published S2I images. Because the S2I images, we publish all of these existing UBI images for things like, Java 17 runtime, Java 21 runtime, all that kind of stuff. All we've done in Paquito is we've extended those and turned them into Paquito run images. So once this extension's finished running, it will swap the intended run image from UBI minimal to becoming the appropriate runtime image. So in this case, Java 17 runtime. That's it. So we've finished doing all of the steps with the DNF installing, and we're now doing the bits where we're actually kicking off. So now we're running the actual build packs. And if we scroll up a little here, we'll see I'm now running Paquito build pack for Maven. You see all of these arguments that have been set, and we can see that there's some arguments in here as well for Quarkus package type fastjar. That was the Quarkus build packs doing. It ran and forced those flags to make sure that we'll end up with something that will work for the rest of it. And then we see that it's compiled the application. It's going to do it. So this is going to go off and do Maven batch mode, all the rest of it. So this is it running the whole Maven build. And this should cache as well. If you rebuild the same project repeatedly against the same image, then it shouldn't have to go and download everything again. But we're quite aggressive on what we said not to cache.
And how does it do? Like, does build pack make use of what's it called? The names like in Docker, you can have like build a container, but you can also have a build two-phase multi-stage Docker file. Is that what it's called?
Yeah.
Is that what build pack is doing, or is it actually containers that build something and you put it into the next container?
Right, exactly. So there aren't multi-stage Docker files because there are no Docker files, with the exception of the one that we were using from the extension to install Java. Yeah, the rest of the build was, as I was explaining earlier, that it creates layer directories. And each of the build packs can contribute to layer directories, and those layers are then put on top of the runtime image. So the reason you'd do a multi-stage build is usually because if you think of a Docker file, it's a combined build and run staging simultaneously, because the reason you do multi-stage is because you essentially want to have a lot of stuff laying around when you're doing your build, then a different lot of stuff laying around when you're going to do your run. You don't need to worry about that with build packs, because the run image is a physically separate image from your builder image to begin with. So your run image starts out without all of the gorp that you didn't want in there. And it doesn't matter what you install or what you leave laying around in the builder image. You don't have to do that multi-stage trick to get rid of it before you create your final image, because only the parts that you cherry pick as this is for the run image in the layers directory will ever end up in the production image.
Right. But this is well, I was kind of hoping you get to like, oh well, build pack actually what they translate into is a multi-stage Docker file.
No, it does not. It never actually translates down into a Docker file at all. It's a very different way of doing this stuff. But
in fact, a build pack is multi-stage. It's not a way of doing the same thing that multi-stage Docker files achieves. Kind of.
You can consider them to be two things solving the same problem, but yes, they're not. They're very different technologies. So that built the complete app. But if we wanted to, we could have. There you go. So here's one where we're going to build it, and we're going to swap over the builder image we're going to use. So that built using the UBI builder, and as you look somewhere near the end of it for executable jar, then we see it go through this bit, adding layer, and then we see build pack phase is complete, application images at user Quarkus app, blah 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 blah. And we could run that if we wanted to, but it's a sample app. It won't do much. It will display the Quarkus banner and then will disappear again. But we could build using the Paquito builder. So instead of using the UBI one, we could use that one. But let's have a look first before we go in. So if we do pop an image list, I think it is. Yeah. Then there's the one that we've literally just built. Don't get used to this bit as well. Every build pack image you ever build will be created 45 years ago, because they all have exactly the same date timestamp. And the idea is they have the same date timestamp for all of the files inside it. The intent here, which doesn't hold true for the UBI builder, the intent here is that if you build the same code into the same image, you will have the same SHA checksum on your image.
Gradle does the same thing. It's like 1970, 1st of January. Well, okay, fine. This is later. It's like 1980. But I always want them to be. Why can't I give you a SHAR? Like, take the timestamp from my SHAR, put that into everything. Because then you actually get something that is, because this means nothing. Like,
there was a RFC towards Docker and Podman and all the rest of it at some point to say, look, enough tooling is now doing this that we need to start having a way to say that this date timestamp doesn't mean 45 years ago. This means it's a fixed time. This is a fixed image. The dates and times in it are meaningless, but you required us to have them, so they have to be the same. Otherwise, the SHA hash won't be the same. And that was the problem.
But just being able to give it in the build, say, hey, this is the time. Anyway. Cool. Okay.
Do not need that image, even though it worked anyway. Doink, there we go. So if we go up here, you'll see that there's an awful lot of metadata in these images. But you can see that this is coming from image for OpenShift providing OpenJDK 17 runtime. So this is definitely a UBI-based image at this point. We've got all of the other bits and pieces that the UBI 17 run image does in there. It's literally just that image, but with our data on it, with our application layered into it.
So what was it that enabled that? Was that just the default values?
Yep. That's all we built. That's the command we ran.
Yeah, okay, got it.
Yeah, and that ran complete against the UBI builder. Whereas if we run using this one, which will run specifying -d Quarkus build pack JVM builder image of Paquito build packs builder jammy base, I'll pass another flag to rename it to something else so that it won't overwrite the image we just created, and set that off. That will take a similar amount of time to run, and then that will end up with a Ubuntu-based image with the same Quarkus app on it. And you can change all sorts of bits and pieces. There's So whilst that's running, we'll have a quick look at here, because here's the official docs. Is that too small?
No, I think maybe zoom in a little bit. But yeah.
There you go. So this is the stuff for build packs that add zip, so you can do your Quarkus extension ad, or with Maven. And then we support all of the standard container image options that are here that are present common across all of them. But then we've also got the build pack options that allow you to change the builder image. This one, if you are doing native builds and you have a custom builder image that supports it, you can specify it via this. We don't have a default for this at the moment because we don't have one. Life cycle images. Sorry, go ahead.
Just in so the base image that's being used here is coming from. Is that coming from the build pack extension?
Yep. No, it's coming from Quarkus. So Quarkus has the container image extension.
Yes, which has a base image that's being used.
And the container image extension has an internal default of I will use the UBI base image. And I will need to update this within the next release of Quarkus so that it doesn't use Potato Community anymore, because the default for this one is Potato Community, and there you go. Potato Builders I've promoted recently from Potato Community to Potato Build Packs, which is a big thing. Because when we started off doing this, this was in April, beginning of April, we moved over those images. And we're just waiting for all of that to finish.
All right, so just make sure. So in today, when you use the Docker file generation, there's a property in Quarkus, I forget what it's called, that says what is the base image for Docker. Are we that's being ignored in this one, or rather, it's not being listened to.
Because we're not using the Docker container image extension. We're using the build packs. So what we're using here is JVM builder image, which is the one that says which builder that we're going to use for building this Quarkus application. By default, we're using Potato Community Builder UBI Latest, which works fine. Moving forwards, that will become Potato Build Packs Builder UBI Latest. That's a small change, but we'll push it through later. Lifecycle image, if you've got a lifecycle images, or if you want to use a specific one, and CNCF build packs publish lifecycle images for every version of the lifecycle, then you can specify that there. You can force the platform level for the build. This is a weird one. Remember how I was saying that a platform implementation has to implement multiple versions of the spec, and that a builder image can claim compatibility for multiple versions of the spec? Yeah, well, it turns out that some of those platform versions have issues, or can have issues, I should say. I mean, I reported the issues to the thing, but we can't go back and fix issues in platform specs or lifecycle specs, because if they're inherent to that particular level of the spec. So it can be handy sometimes to force the level of the build to a particular level. So that's something we provide here, that if you want to make sure that by default, I think we pick the lowest version of the intersection of all compatible versions. So like we've got our version list, the builder has its version list, the life cycle can have its version list. We intersect all of those to find which is the possible set of versions that could run with, and we just pick the lowest one from that set. But it is a set, and there could be multiple in there. So if you want to change it to a different one, we provide a flag to let you override. There are flags here to pass environment variables down into the build pack build. One of the most common ones for that is if you want to change the Java level that it's being built with, BP JVM version. You can set that to something, and it will affect then which version the build pack will try to force for the install, and the whole build shifts up to that level. So you can set that to, say, test the whole project against JVM 21 when your POM and everything else is still saying 17. It's a nice trick. All of the registry ones here are ways to pass authentication information for remote registries. So say we were trying to build an image against K.io and you want to upload it directly there. Well, you can pass your username, password, or username and a token if you're using bearer token auth directly here by using Quarkus build pack registry user. You put K.io here instead of registry host, and then you put the username after that. Set all of those in, off it goes. What else have we got? We got the run image. I wouldn't customize that one. This is handy if you're not using extensions, but when we're using extensions, the run image gets swapped out all the time. So this becomes void. These are handy, especially if you're running from GitHub Actions, which have very variable time frames for when trying to pull things. Pull timeout seconds. And then I implemented a back off and retry so that, if a timeout fails, it will retry for a number of times. But every time it retries, it will increase that pull timeout by a number of seconds. I mean, for those of us who studied Ethernet back in the day at university and remember, there wasn't intent here.
When you're saying with Kubernetes, the way it kills stuff is like kill, wait.
So Docker host and Docker socket, these are escape hatches, right? I'm pretty confident now that in the current auto configuration stuff, you won't ever have to use these. But if for some reason the auto configuration is picking something you don't want, for instance, you have Podman and Docker installed concurrently, but you don't want to or cannot uninstall Podman and you want it to use Docker, you'll have to use these to force the values to what they need to be. Use daemon. This defaults to true because the very first release of this library and the very first release of this container build pack extension for Quarkus has used this as true, so maintaining existing behaviors. This sets whether or not we're using a daemon-based build or a registry-based build. The registry-based build, I say it would build directly into the target registry, but most likely if you're using somewhere like K.io, that means that you're then into needing to use authentication to be able to make that build succeed, which is another kettle of fish. Docker network. If you're not using a remote registry and you're building on Linux, probably not Mac or Windows, you can set Docker network to host and you can host a local registry in your Docker daemon. And because the build will share the same network as your host does, it can then reach that registry and you can build the whole thing locally within the registry using registry mode, unauthenticated, and everything will work fine. Honestly, this is such a mess when it comes down to how to authentication and runtimes and registries. It's not, there's no consistency yet. No consistency out there.
Sure.
Log level, because when we ran that, it spewed lots and lots of stuff. That was at the lightest level of info. If you have trouble, then obviously we might want to raise this up to debug and see what the actual problems were that was happening. And timestamps is whether or not the logs included that as they were flowing past, because you can see when we get, oh thanks, it locked it again. Useful. So you can see as we go through here that every single part of the build pack log was preceded by a timestamp, which if you're just in the interest of trying to minimize storage on disk, you might want to turn those off. But yeah.
This is a lot of because it locks out the build.
Because you see not just the full Maven build, you also see the full DNF install Java log when it went off and did all of that for the extension. So there's no way to avoid it. But build pack logs will never be like 1 or 2 lines. They will always be hundreds, if not thousands, of lines long, and many of those lines will be useful for debug if it hits issues.
Cool.
Yeah.
Right. So do you have more?
That's it. I'm coming in just at the end of the hour, which is perfect considering apparently no.
Oh yeah, because I want to kind of summarize. Like, you've gone through all this. And you showed that hey, it's there, it exists. I get like who can we just kind of spend 2 minutes like who is this for? Like who wants to pick build packs over Docker or Jib or something else? Can we just
absolutely? So I mean, build packs has been rising in popularity as a way of containerizing an application and producing it. It comes with its own advantages that way. So I think build packs is for teams that have already got an interest in build packs, or if you haven't chosen a solution yet and you are looking for something flexible that will accommodate more than just a Quarkus app. So if you're in a kind of shop where you've got Quarkus apps being built and you've got Node apps being built next door that are going to be talking to the Quarkus apps, and you want some consistency in the way all that's happening, you might consider using build packs with a builder image that manages everything so that you've got control over how the whole build process works. And then all you need to do is tell your Quarkus devs, just use this builder image, and that's it. The rest of the how does it work is taken away from them. They don't need to worry about how the build did it. You can have some architect somewhere else look at how their custom builder image, what they put in it and how it builds it. Or indeed, they might just choose to stick with the stock Paquito image and say, that's good enough. We're willing to flow with that and stick with it.
And when so today, if you go to Heroku or other cloud vendors that supports build packs, this would be an option for them, or are they all the small asterisks? It has to be one that has a compatible with Paquito XYZ, or
so in theory, any platform that is supporting any I say platform, this is seriously overloading terms now, isn't it? Any runtime vendor out there that is going to be doing builds using build packs that allows you to specify your own builder image should be able to work with either a UBI builder image or any Paquito builder image. This is the whole point. These things are supposed to be swappable and interchangeable. The idea with build packs isn't to create a closed ecosystem where this company has to use this one. The idea is that we create an ecosystem of places you can use build packs, and then build packs that you can use with those places. And of course, the build packs tend to be packaged in builder images that belong to an ecosystem. So, and it's only when you discover that ecosystem doesn't meet your needs, you have the choice. Do you contribute to the ecosystem and improve it, which is what we've been doing? Or if you are a closed source proprietary company that wanted to make use of it, do you decide at that point to create your own internal build pack ecosystem where you generate your own custom builder images that are tailored precisely to your corporate environment? And that's one thing about build packs is it lets you go down that road and have that kind of management of your build structure.
Because that was kind of what we looked at in when we tried to look at build packs for like Red Hat's builder Quarkus. Mm-hmm. But we've stopped very quickly because we end up realizing we have to maintain a ton of stuff that just
I mean that's the difference really between the way we went with Paquito and the way that I remember as well. We were looking at it from a Red Hat perspective. Yeah. Did we want to create an entire Red Hat ecosystem of builders and build packs? And that became problematic because the more we looked at it, the more we were going to be basically duplicating effort that was already out there in the community with things like Paquito. The more we were going to be probably maintaining an image with far less usage, so it would have less exposure for bugs, for security issues. It made more sense to become part of a bigger organization out there and contribute to them than it did to try and recreate the entire world within our borders.
and what I understood from you is also like, if you are an organization, let's say you I know Spring has a lot of early days of build pack.
Yeah.
And if you want to use Quarkus, then here's a way, and you can do two things. Either you can just use the Quarkus build pack plugin to do its thing, or you can do a little bit of setup, and then you can use the pack command that is in there.
I mean, pack. If you want to use pack works just as easily as what it does. So history.
And I guess you can even use Spring's approach with Quarkus. You just won't be using product supported.
I only got pack version. Let's see if I can guess it. Pack. Build path dot. I need to give it a name. That should be roughly it. Oh, I have to set Docker host as
well. You can run it the same way. Yeah. So
inherit, if I remember. And then I also have to set Docker host.
It doesn't matter. Pack is the same thing because I know there's some that provide pack execution, and so basically, if you didn't think Quarkus had build packs, that's definitely not true.
Yeah,
it supports build. And the reason why we haven't talked that much about it is mainly because we wanted to make sure that the build packs we're running actually is possible to, you can control the base images for you to run on a stack that you fully support or can get fully support for.
Exactly. So,
whether that is or someone else.
Yeah. And that's you can see pack there is now running the same build that we just ran from inside. And the log information is fairly similar because we were looking at this and saying that things. Oh, do you remember when I was saying that detecting would pick which things were going to participate? This is what we're saying there. So it's telling us that 13 out of 30 build packs will participate within this build. And you can see that we're using the Java extension and the Java build pack, and then Quarkus, which is setting up all of our Maven flags, CA certificates for custom stuff, Bellsoft Liberica, which is the full Java implementation from Paquito that will back off because we've already done our stuff, Sift, Maven, executable jar, a bunch load of others that are here, but they only kick in depending on whether the application met criteria as it gets further down. Same as Liberty's not going to do anything in this build, but it's there in case when you're doing a Java build, once it's built the application, it says, oh, hey, I need to plug this in next. So we've got a whole bunch load of build packs, including the Spring Boot one in there as well. Because again, we're just taking what was the Paquito Java meta build pack that has the set of things needed to build Java and adding it straight to ours.
And I guess there is some config for you to turn those on or off. Like, I don't want any of them.
No, you don't need them. I mean, you don't need to turn those off in this build because although they're participating, they won't actually do anything.
Yeah, but just if you want to have explicit control, you can.
Yes, you would build a custom builder and remove these build packs from the builder. You can't just disable a build pack by name.
Cool. And my last one was the you mentioned Maven in the start. So I guess does this mean that Gradle is completely off the table, or?
For Quarkus, I believe, but I could be wrong. I'd need to double check. But I believe that the Quarkus build pack is only setting the flags for Maven. So, although, I mean, build packs will run just fine with Gradle. If this was a Gradle Quarkus project, it will attempt to build it. But you will be responsible for setting the flags that the Quarkus build pack would have set. You'll need to set it up to do fastjar as the output. You'll need to tell it where to find the stuff. I mean, honestly, if you build it once with Maven and then scroll up and see which flags were set for Maven, you should be able to derive which ones are then being set.
Oh, maybe I missed this. Does this assume fat jars?
No. What happens is that when the Quarkus plugin, when the Quarkus build pack runs, it notices this is a Quarkus application, and it sets the flags for Maven to set the output jar type. So it overrides what you have in your application properties. Yeah.
Okay. So that's my question, because sometimes whether I use build pack or not, I would like to use the non-fat jar because that is a layer.
So it's using fast jar at the moment.
Oh, fat.
Fast.
Oh, so it's not okay.
It's not a fat jar anymore.
So it actually does. It will automatically use the exploded app content, and so it does not support fat. Okay, got it. Yeah, but that's better than the other situation. Okay. Yeah, but again, this is just one of the advantages / disadvantages of build pack, right? There's an opinionated packaging, and if you wanted to do a different one, you will make a variant of this one to be a bit different. Yeah.
There you go. So when the Paquito build pack for Quarkus ran here, then it writes out these parts for BP Maven build arguments and BP Maven built artifact that customize how the Maven plugin later on will do its job. And then when we hit Maven here, we can see what those are. So the additional build arguments here, you can see that it is passing package -d skip test true, -d Maven javadoc skip true, and -d Quarkus package type fastjar. So it's forcing the Maven build for Quarkus here to use the right fastjar type so that it can understand the output. And then the built artifact line, it then tells it to look in target Quarkus app lib, target Quarkus app star.jar, target. So it tells it how to find the stuff and how to put it back together again.
Yes. And how does the so I guess a greater support could just be but it's the same arguments basically, the Quarkus package type.
Yeah, exactly.
But I notice here it's skipping test. Is that a normal thing for build packs to do, or they expect the test to run somewhere else, or how does it?
Well, yes. I mean, the thinking with this is that you're just building your application to run. That you're building it for production.
Yeah.
That if you look, if we go all the way back up, this was a pack build, wasn't it? So it's not going to help. But do you remember that we were running these via Maven? Yeah. This is our Maven. So Maven's already run the tests. Maven ran all the tests locally on your system, as part of the build. And then after it finished all the build, then it kicks in the build pack part for container image extension that then goes and does it all again. Test returned.
It ran the test assuming it's a fat, maybe a fat jar, and not a fast jar, and on a different platform than you were actually building. So,
absolutely. I mean, there's a benefit to doing it. And again, this is stuff that if we want to change, we can happily accept PRs for the Quarkus build pack, so we can have flags to control it.
Yeah. No, I was just curious if that's a normal thing in like a Spring Boot or Micronaut or Java, if they skip the builds inside.
So Spring Boot doesn't actually do the build again inside the containers. Spring Boot builds the equivalent of the jars locally, like our fast jar, whatever. And then when the build runs inside the container, it doesn't rebuild from source at all. It just takes those built artifacts and layers them straight into the
that was one of my other questions, because there's some advantage to that. Because basically you go like, oh, these are the jars I actually tested. And I was wondering, because we have this in Docker too, like our Quarkus Docker file currently assumes that the jars are built outside, which is fine in some cases. But for example, if you go to some cloud providers, they assume the Docker file is all self-contained. And so my other question was, do we have a mode of saying, hey, I'm going to give you the jars and you build from there, or as you do now, I'm building from source? But I'm assuming you're saying that will require another variant of the Docker builder, the Quarkus builder.
I think you could probably do it today, but you would need to massage what the project looked like before the container image extension copied it over. It like the logic inside the build packs that's running is the same regardless. So, and that logic is the same stuff that understands how to take a Spring Boot jar file and turn it into a working container. So if we were to set up the local project to create a directory that was fed to container image build packs that actually then went off and contained just those jars, it would do the right thing at that point. But we might need to have a staging directory where we copied stuff into and then ran the build pack stuff against that sub rather than it. Doable using pack, slightly harder using the built-in stuff, I'd imagine.
Sure. Okay. Cool. Anyway, we are way over time. This was really useful. And the main message is, if you want to use build pack, that is definitely supporting Quarkus. And a bunch of other stuff too. Very cool.
So 3.2.2.1, the latest stuff that we've got, that's the one that's got all the good stuff in for Podman and Docker and all the auto configuration. Definitely worth making sure you're running at that version of Quarkus if you're going to play around with this stuff. If you're going to run with Podman, please make sure that you've updated to at least Podman 5.4.2. 5.4.1 has a deadlock issue that we are guaranteed to hit every single time, 100% of the time, using build packs. So don't, and that's the one that comes by default with Fedora, whatever version it is that I installed in this VM. So you will need to update. The updates are out, but you will need to do those updates. And as I say, make sure that you've got, if you're using Podman, make sure you've started the user socket or you've started the Podman socket. Docs for that are everywhere. Change the timeout as well, which is fully documented on the test containers website as to how to change timeouts for Podman. If you're using Docker, it just works badly.
Got it. Okay. Well, thank you, Ozzy. And see you next time.
Take care.